Welcome back to another math video here at Math Rocks with Mr. Cox. In this video, we're going to be looking at different polygons. We have what we call regular polygons like this one over here, where all sides and angles are the same or congruent. And we also have irregular polygons as well. And we're going to be looking at three different kinds of angles that appear in these polygons. We have interior angles, central angles, and what we call exterior angles. So you'll learn what those are and also how to find their measures. So if you want to find out how to do all this, stick around and find out. Let's get it on! So I've gone ahead here and drawn a pentagon. There are 5 sides here, 5 angles. It's also irregular because the angles and the side lengths are not congruent. So once again, this is a pentagon. I'll write that up here. And we know the sides, the number of sides is 5, so we write n equals 5. So let's figure out how to find the sum of the interior angles first. So first of all, you need to know what an interior angle is. And all that is, it's the 5 angles on the inside of the polygon. So I'll go ahead and label those over here. And we're going to try to figure out what the sum of that is. And what the trick is to go ahead and find any of the vertices. So I'm just going to pick A because it's sitting right here. And I'm going to go ahead and I'm going to draw a line out to all the other vertices. Well, A to B is already on the actual polygon itself, but I can draw a line from A to C right out here. And I can draw one from A to D as well. And then I can't draw one from A to D because it's actually on the polygon itself. But you'll notice here is that by doing that, although it has 5 sides, I can create 3 triangles. And so it turns out if I want to find the sum of the interior angles here, all I have to do is this. I know that the sum of the angles in a triangle is 180. So I've got one triangle over here, I got a second one here in the middle, I've got a third over here. So I know the angles here that make this up in triangle 3 would be 180, same thing for angle 2, same thing for angle 1. So really all I have to do with the pentagon is take 3 times 180. And when I do that, I'm going to get 540 degrees. So that's how it works for a pentagon, and I will show you also the formula, don't you worry. So if you really are a formula person and just want to skip to it, you can kind of skip ahead in the video and you'll see the formula works for all figures, but just know for a pentagon it'd be 540. All right, next up we have this thing, and it is called an exterior angle. And what you're going to do is you're going to extend the side. So I just extended this side out. I'm going to extend this side out a little further too. Same thing over here. Keep going and going and going. And what happens is these angles that stick out the end would be considered what we call exterior angles. And so we're going to look at how to find the sum of them in this actual figure itself. So I'm going to go ahead and say if that's angle A, I'm just going to call this angle F. And I'm going to call this angle G. And this one over here, H. And this one over here, I'm going to write it kind of sideways, that's my I. And over here, this one would be J. So what I can do is I can say a few things. First of all, you'll notice by extending out the line, it basically makes it so that angle A, which is the interior angle, and angle F, the exterior, form a straight line, therefore they're supplementary. So I can literally say right now, A plus F equals 180 degrees. And I can do that for all the others. So I can say B plus G would equal 180. And I can do that for C and H. So C plus H equals 180. And we can say D plus I also equals 180. And finally, where you could say E plus J, those 2 angles would equal 180 degrees. All right, so we're kind of on the way here. And by the way, once we figure out the answer here, you'll love this because it works for all polygons no matter what. But what I can do is if I add up all the 180 degrees here on this side, I am going to get 180 plus 180 plus 180, I get 900 degrees. Okay, so that's going to be on that side. And then what you'll notice is if I add up everything here on the left, a couple things are going to happen. Number one, I'm going to get these 5 angles added up together, and I'm going to get these 5 angles added together all on the right side of the equation. And here's the trick. A, B, C, and D would be all of the interior angles. And we know what it is already for a pentagon. We just figured that out. The sum of the interior angles in a pentagon is 540. So these 5 angles here are 540 degrees. So therefore what I can say is over here, I can say 540 degrees plus all the exterior angles right here. So it would be F plus G plus H plus I plus J. I'm just going to write sum of the exterior angles. And therefore, if I go ahead right now and subtract 540 degrees from each side, when I do that, the sum of the exterior angles, which in this case is F plus G plus H plus I plus J, the sum of the exterior is 360 degrees. And it turns out it doesn't matter what figure I have, how many sides it has, or if it's regular or irregular, the sum of the exterior angles is always 360. And so that leaves us with the final type of angle called central angles. So first of all, what is a central angle? And all it is that you want to find the center of your polygon and you want to go out from there to each of the vertices. So I'm going to do that right now. And a central angle is nothing more the angles in which the vertex is actually the center. So for instance, that is a central angle because it goes from C to the center out to D. I'm going to go ahead and make another central angle and another, and here's another central angle and here's another. So what you'll notice is that when you look at all of the central angles, in this case 5, they make a circle. And in fact, it doesn't matter what kind of polygon you have in terms of number of sides, they're always going to make a circle in the middle. And as we know, a circle has 360 degrees in it. So therefore, if you're talking about the sum of the central angles, it is exactly the same as a circle, which is 360 degrees. So those of you who are looking for some formulas here are the formulas all typed out nice and neat here for you. And this is true for all polygons. It doesn't matter if they're regular or irregular, it works for all of them. So the sum of the interior angles is always the number of sides minus 2, and then you multiply by 180. The sum of the exterior angles is always going to be 360. The sum of the central angles is always going to be 360. And then another little twist here is that if you have one interior angle and its exterior angle that goes with it, their sum will always be supplementary 180 degrees. So once again, this works for all polygons. So what about if we had regular polygons? So regular, once again, means all the angles and all the sides are equal. So if we're looking over here, and I would do this drawing all the interior angles here. Here we go, draw them in. What I know is all of those angles are going to be equal in measure. And by the way, how many sides does this have? Well, it's an octagon, which means we're going to go ahead and we're going to have n equaling 8 in this case here. So if I want to find the measure of each, all I need to do is find the sum of the interior angles. Well, we know that the sum is going to be this number minus 2. So I'm going to say 8 minus 2. And I'm going to take that answer and multiply by 180. So that would be the sum of all the angles. And if I want to know each one, I just go ahead and divide by the number of sides. So it turns out that 6 times 180 is going to be 1080 or 1080. And we're going to go ahead and divide by 8, and therefore it's going to be 135 degrees. So each of these angles over here, whether it's the angle I have the arrow pointing at or any of the others, each one of them is going to be 135 degrees. If I want to know the measure of each central angle, well, I know their sum is always going to be 360 because it's in the center and it makes a circle. And then all I have to do is divide by 8. And when I do that, I will get 45 degrees. And then finally, exterior, I know the sum is always 360. There's no calculation needed. I divide by the number of sides, and it will also be 45 degrees. So you'll notice if you have a regular polygon where all the sides are congruent and all the angles are congruent, the measure of a central angle and an exterior angle are always going to be the same. And now let's go ahead and just throw out the formulas for you here. So if I want to know each interior angle and it's a regular polygon, it's 180 times the quantity n minus 2 divided by n. And exterior and central angle, the measure of each is going to be the same. It's 360 divided by the number of sides. And a central angle will equal the measure of an exterior angle as well.
If you like what you've seen and heard so far, please like, comment, or subscribe. Thank you, and back to part 2.
Now let's go ahead and apply it in some actual problems that you're likely to see in your textbook. So for instance, let's say you have a regular decagon. Well, a decagon means deca is 10, so that means we have the number of sides here being 10. So if I want to know the sum, I'm going to take that number and subtract 2, so that's 8, multiply it by 180, and when I do that, I get the answer of 1440, so 1,440 degrees. If I want to know each interior, what I'm going to do is I'm going to take that sum, because that's all of them added together, and I'm going to divide by the number of sides. So we would get 144 degrees. If I want to know the sum of the exterior angles, well, I don't have to think very hard because it's always going to be 360 degrees. And if I want to know the measure of each exterior angle of this regular decagon, I would just take that 360 and I would divide by 10. And if I do that, I get 36. And then finally, if I want to know the measure of each central angle, once again, I could either know it's the same as the exterior, or I can just take my 360 divided by 10 again, and I still get 36 degrees. So let's say all I know it's a regular polygon, so that means all the angles and all the sides are congruent. I know we have a central angle of 15 degrees. How many sides does it have? So it's kind of working backwards a little bit here. So here's what I know. With central angles, if I take 360 divided by the number of sides, it will equal, in this case, my central angle here, which is 15 degrees. I'm going to go ahead and make it into proportion. So I get 15n equals 360. And then if I divide both sides by 15, I will get the answer. And the answer here is 24. So n is 24 sides right there. And really all you needed to do at the very beginning, just to show you this, you could have just taken 360 and divided by that exterior angle, and that would have gotten you the same answer too. But that's kind of the long way of showing the work. And here's one other problem. What if it's a regular polygon? We have an interior angle of 160 degrees. How many sides does it have? Well, really, there's two ways to handle this, and I will show you my favorite way. I'll call it way number 1 over here. What I do is I turn that interior angle, and I don't think of it as that. I think of that as what would be my exterior angle. So here's what I always know. Interior plus exterior angles always are going to equal 180 degrees. So therefore, if I know my interior angle is 160 degrees, I know therefore my exterior angle must be 20 degrees. And then all I need to do is take, because the sum of the exterior is always 360, if I take my 360, which is the sum of the exterior angles, and divide by one exterior angle, and I do that, that will give me the number of sides. So in this case, your n would equal 18. So that's what I like to do. I think it's a little quicker. Some people might prefer this method, and what you'd say is, I know the formula for an interior angle is this. It's 180 times the quantity n minus 2 all over n, and I would set that equal to 160. And then once again, we're going to have proportions here, and when you multiply across, 160 times n is 160n, and 1 times all of that would just be 180 times the quantity n minus 2. I'm going to go ahead and multiply it out. 180 times n is 180n, and 180 times negative 2 would be negative 360. And then what I'm going to do is I'm going to add 360 to both sides and subtract 160n. So when I do that, I'm going to get 20n over here after subtracting the 160n on both sides. And when I add 360 to both sides, I get this. And then, of course, we're going to divide by 20. And you'll notice it's really the same calculation as over here. And you get n equals 18. So you can do it either way, whatever way works best for you. And that's it, you guys. Hope you enjoyed the video, and hope to see you again.